All right, welcome to this little further introduction to chemistry. This time we're going to be talking mostly about, well, entirely about the chemistry of water. So, why water? Why not some other compound? Because water is hugely important, as you already know, to life on Earth, which of course makes it hugely important to biology. Okay? Now, as you already know, water's chemical formula is H2O, 2 hydrogens, 1 oxygen. This hydrogen here and this oxygen here and this hydrogen over here are covalently bound to each other. So a covalent bond exists here and here between these atoms, okay? Remember that covalent bonds are very strong, okay? So these bonds here and here are going to be strong. They're going to be pretty permanent, okay? Not changing. Now, that's just some basic background. Some other basic background is, of course, you know water is unique and very important for life on Earth. It has certain properties that make it essential for life as we understand it. Okay? Life as we know it could not exist without water because of certain ways water behaves. Also remember, 75% of the Earth's surface is covered with water, so that makes it obviously just hugely important on the planet. It is also, interestingly, not only most abundant on Earth, but most abundant in you. It is the most abundant compound in really all living things. But please remember, just because you contain a lot of water does not mean that you are substantively made of water. You can think of a water balloon. The water balloon may be really full of water. We pour the water out, you still have balloon. All right, you are kind of a water balloon too, but you're not made of rubber. You're made of organic compounds like maybe protein. So picture yourself as a big protein balloon and you're full of water. We pour out the water. You still have the stuff of you. You're just probably not working very well anymore because you really need the water to fill you up and do things, okay? So, what is it about water? Why couldn't you be a balloon full of something else besides water? What is it about water? It all begins with oxygen. Oxygen is electronegative. You need to remember that word and you need to associate it with that atom, that element. Okay? Now, what is electronegativity? What this means is simply that oxygen loves electrons and it is not going to share them equally in a covalent bond. It will share them, but it won't share them equally. So if this purse is the electron and I am oxygen over here and this little lady is a hydrogen, I am going to not steal it from her. I'm going to let her hang on to it, but I'm going to hold it really close to me. And she's going to kind of be stretched out trying to grab what little bit of it she can. Okay? That's how you need to think of oxygen. Oxygen does not play nicely. All right? So, in real life, okay, there we go. In real life, what you're looking at more is electrons getting pulled from a hydrogen toward the oxygen. Electrons getting pulled from hydrogen toward the oxygen. So that we end up with more negative, well, it doesn't show up well, more negative charge near the oxygen because it's holding those negatively charged electrons, and more positive charge near the hydrogens by default because they've kind of lost custody of their electrons a little bit. They haven't lost them entirely, but they're being held more towards the oxygen. Okay? So, what does this electronegativity of oxygen mean really for the water molecule then? As a result of oxygen pulling electrons toward itself, that means the two ends of a water molecule are different from each other. Okay? One end, the oxygen end, is going to have a slight negative charge to it. It's not going to be fully negative. It's not stealing the electrons, but it's going to be slightly negative because it's holding them more closely. The other end is going to be slightly positive because the hydrogens have kind of lost their pull on those electrons to a degree. Now, because of this, water is said to be polar, almost just like a magnet has two poles, a north and a south pole. Polarity is when any molecule, but in this case water, has one end that is different from the other. One end, in this case, is slightly negative, the other end is slightly positive. Okay? That's being polar. That's huge. That's really important because it is from this polarity that all other properties of water will be derived. So, water's polarity, again, weak negative charge, weak positive charge, okay, on either end. So why does polarity matter so much? Polarity causes water molecules to truly act like little tiny magnets, okay? The negative ends of water molecules will be attracted to positively charged particles. The positive ends will be attracted to negatively charged particles, okay, just like a little magnet. The polarity of water, it's acting like a magnet, is the one quality of water that causes all of its other important properties to exist, okay? Now, let's talk just a little bit more about polarity and what actually happens. We know that water molecules are attracted to each other due to their polarity. Really weak little bonds that we would call hydrogen bonds, okay, important term right here, are created between the oppositely charged regions of different water molecules, okay? So over here is a water molecule. Here's one, and here's one, okay? But notice, this slightly negative oxygen is just ever so weakly bound to this slightly positive hydrogen right here. And this negative oxygen here is ever so weakly bound to this slightly positively charged hydrogen over here. So, these weak attractions are called hydrogen bonds, all right? They are indeed weak, but that's in comparison to a very strong covalent bond. But they are very much stronger than having no bond there at all, okay? And it's because of these bonds between between separate water molecules, where they're kind of held together, albeit loosely, that gives water all of its unique characteristics that make it so important for living things, okay? So that's it for this portion. In the next portion, we are going to look at the seven properties of water that make it so important for life on Earth. Okay, that's it for now, and I will see you again soon. Take care.